Hello and welcome to another edition. I guess this is volume 4 of Don't Plug In That Old Radio. And today we were going to cover how to align the RF section of your radio without any signal generator or any expensive test equipment. And that's not going to take very long. So we'll get to that in a couple of minutes. One of the first things I want to do is answer a couple of viewer comments. I know I don't always answer comments online, and believe me guys, it just takes so many hours to do this stuff. I try to review them once in a while when I got a few minutes, but if I answered everybody's comments, I'd be there all day. Content creators understand. I present you with a 30 or 45 minute video. There's probably 2 to 2.5 hours of prep work goes into setting up for it. Then I shoot the video, then I get onto the editing station, and I'm not complaining here, I'm just explaining. You get down to edit it, you put all the clips together, and I usually end up watching it myself 3, sometimes 4 times to make sure I got the details correct. If I've forgotten something, I'm putting in a note down on the bottom of the screen for you. It is enormously time consuming, and those who do this understand that. The guys, it's funny, when you get these really nasty negative comments, if you go look at the screen name, there's zero content. They're just people sitting in the corner with nothing better to do than pick on someone. And you got to feel sad for these guys. Their life is so empty. But it just takes so many hours of your time to turn these videos out that when you get done doing that, spending another hour and a half or 2 hours with comments is just overwhelming sometimes. Again, I try to get to them once in a while, and I apologize for those I don't. But I figured I'd take this opportunity to address a couple of them. And one of them was from George 777. Thanks for watching, George. He warned me that if I wasn't careful, that excuse me, I'm looking at notes here while I'm talking. I shouldn't be doing that. He warned me that Fender guitar amp guys were going to come out of the woodwork and be all over me for ruining their amplifiers by changing capacitors. I have tripped over so many audio fools over the year. That's what I call them instead of audiophiles. When you replace the capacitors in these guitar amps, what you're doing is returning it back to what it sounded like when it left the damn factory. The fact that it's all fuzzy and distorted now due to the bad capacitors is not how it sounded. It's because the caps are bad. A lot of these things use 6v6s in the output, those guitar amps. And they have a cathode bias, a fixed bias on most of the Fender amps. The 6v6s, you go online, anything from $10 to $150 because they have to have the black anode 6v6 because it has the warmest sound. I would love to set up a test box with 6 sockets in it and a rotary switch and put 15 of these guys in a room and say, which tube is it as I switch between the tubes? And then watch them come up with things like, well, you know, the acoustics in this room are different. If you want fuzz, add a fuzz box in front of the amplifier. We've got to start preserving these 6v6s, these 6L6s, these 5881s, although 6L6s are being made in Russia today. But they're not the same as the RCA ones. Okay. You want fuzz, ask your technician to change the bias on the preamp tubes. You got 12AX7s, 12AY7s, sometimes 12AT7s. It's easy enough to change the bias on those tubes and tickle them into fuzz and into distortion a little bit. Let's start preserving these very rare, expensive output tubes. And let's get over the fact that the guitar is going to sound, the amp is going to sound a little different when it's working correctly, like it should be when it left the factory. And Joe Jack asked for some advice on, guitar amplifiers. That's the best advice I can give you, is just get ready to be pummeled by the audio fools when you fix this stuff. I worked with a guy, claimed to be a guitar amp repairman, and I started talking to him about leaky capacitors, and I just got this. It was like talking to a Moonie. You just, oh, you gotta have those capacitors in there because they have the warm sound. Take a deep breath, Joe Jack, and just be ready for it. Ronald Bergeron commented, and I can't lay my hands on the schematic that I drew the other day about lifting the ground on the resistor. Let me find that. Okay, we got it. He commented that, and it's a valid concern. I may have sounded brusque when I answered him. It's just that I'm usually short on time, and I'm sorry, Ronald, if I did. It's hard to, when you do an email, the tone is hard to convey sometimes. I wasn't coming down. When you lift this lead of the resistor, all of these voltages are going to go up, and he was concerned that maybe it would damage capacitors down line. And my answer to him at the time, when I answered him online, was the electrolytics and almost everything are at least 150 volts, like these radios here, where they're rectifying the AC line, and it's never above 125. The supply I'm using over here, I'm setting for 125 volts. And I said in the email that paper capacitors are always at least 400 volts. That's wrong. I see a lot of 200 volt caps as well. But still, 200 volts is far and above the safety factor for 125. If I'm dumping 125 through this because the ground's lifted, the paper caps down line are almost guaranteed to be at least 200 volt rating. And as I said to him, I said, the whole purpose of this test is to find out which cap's going to fail so that you don't turn the radio on and burn up other expensive parts. I'd rather have the capacitor fail. So thank you for your comment, Ronald. And again, I apologize if I sounded brusque when I answered. I just, I've got so many things going on at the same time. And hello to Oleg, another white mystery box, buddy. We'll be explaining this in just a second. Actually, I'm going to go into that right now so I can get this off the table. This is basically all you need to reproduce this guy right here. A container. This power cord can go directly into your existing dim bulb setup, right into your variac and isolation transformer dim bulb setup. You don't need the Heathkit supply because with this diode and that capacitor, you've got your DC voltage supply. A single pole double throw switch, and again, this one happens to be a center off because I have a drawer full of them. That's not necessary. Just a standard double pole or single pole double throw switch, and again, like I said in the video, a three-way light switch will work. And some kind of terminal strip to mount the goodies on. And of course your lamp. Your lamp is critical to limit your current to 50 milliamperes. If you want to really gild the lily, you can add a 0 to 50 or a 0 to 100 milliamp DC meter. 50 milliamp is more than sufficient because you'll never see more than 50 milliamperes of current because it's limited by the lamp, and you'll get more accurate indication down on the low end with the 50 milliamp if there's any leakage. But make it as simple or as pretty as you want. A couple of old test leads, cut one end off, and you can use the other end of them coming out of the box to clip into your circuit. It's an hour project. Once you got the parts gathered up, everybody should have a diode and a cap in their junk box. It's so simple to put one of these together, and it's so much safer to bring the radio up after you know the caps are safe. So I'm going to clear that off the table, and we'll be right answer back. The question I'm sure is coming, that white box that I used just then for the demonstration was a homemade noise bridge, noise pulser for tuning an antenna tuner without putting a signal out on the air. You flip the switch on that, turn it on, and you hear this pulsing sound in your receiver. You adjust your antenna tuner until the noise completely goes away and your antenna's tuned, and you never have to transmit anything on the air. Unlike these morons you hear tuning up for 10 minutes at a time on top of a DX station, you hear them tuning their amplifiers for 10 minutes or tuning their antenna tuners for 10 minutes. It just drives me freaking crazy. And there's another thing that drives me crazy is MFJ makes this box that pulses your amplifier, and these guys will get on the air with this thing going pop, 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 and your automatic notch filter can't keep up with it. It just wipes out the band while they're tuning up. Tune your damn amplifier into a dummy load. Use a noise bridge to tune the antenna tuner. You never have to put a signal on the air. Okay, enough of that rant. This is just another AC/DC set that I grabbed for a demonstration. And what I've got going on here is I have my dim bulb box set up, plugged directly into the non-isolated line on my Variac, because we're at the point now where the radio is repaired and working and we have everything up and going. So we're ready just to use regular line voltage. I'm going to make sure this is off. Well, I'm going to plug into my dim bulb setup with the radio. And the other day I talked about how when you turn some of these sets on, the weakest tube gets slapped with all the current, and eventually that's what takes the heater or the filament out of them. Anybody who's worked with these little AC/DC sets for any length of time, if it has a pilot light, you're used to seeing a light like the sun come on from the pilot light, and then it dims down, and then it comes back up to brilliance as it warms up. And if it's all full of miniature tubes like this, I'm sure you've seen occasionally one of the tubes that, again, when you turn the set on, lights up like the sun and then dims back down, because that's the one getting smacked. They're all supposed to draw the same current. They never do. There's manufacturing tolerances, and the weakest link always gets hit the hardest. We can eliminate that problem by using our dim bulb to bring up our radio. We don't need our Variac, we don't need our isolation transformer, but if you have another dim bulb set up, it will take care of that shock for you. Now I'm going to turn this set on and watch the lamp. So instead of the tube taking that hit, the lamp took that hit. And as soon as it's been on for a second or two and the light dims down, you can switch your radio over to full power. And that racket you hear is the switching supply running the camera. But if you've got a bunch of old sets and you want to turn them on from time to time, and you don't want to take a chance on blowing out a tube filament because you see one that lights up like the sun, that's a cure. A better solution would be one of these negative temperature coefficient surge suppressors. These are left over from my working days. And I know people are out there, oh, those are thermistors. Well, the manufacturer calls it an NTC, not a negative temperature coefficient resistor. So that's what I'm going to call it. You want to argue with that, call the manufacturer up. What these are is a resistor that when they're stone cold, let's take a look at some of the values here. For instance, this one would be 80 ohms stone cold to soak up the surge, and it's rated for 1 amp continuous current. When it warms up, when it gets hot, it drops to 1.7 ohms. We have some here that start at 10 ohms and go to 0.26 ohms when they're warmed up, but this one needs 3 amps of current. The downsides, there's a couple. One, they get real hot. So you have to find a place under the chassis somewhere that's away from other components. But the real problem is I can't find any of these, and I looked for about half an hour this morning and I probably missed it. Someone out there probably knows where to source them. They're rated for a particular current. This one's rated for 6 amperes. When you're putting one in one of these radios, you need to find something that's going to run at a steady state current. One of these that's rated for 0.2 amperes. Most of these radios run 150 to maybe 270 milliamperes when they're running on the AC/DC sets, and this is only really a problem on the AC/DC sets. The sets with the transformers with all 6-volt filaments all come up together. It's not a big deal. It's on these AC/DC sets with a series string filament. One tube is always getting pummeled every time you turn the things on. If somebody out there knows a source of these that are rated for 1/4 of an amp, let us know. Put it down in the comments and let us know, because it would be great to put these in the old AC/DC sets. Let these take the hit when they come on, because they drop to almost, an extremely low resistance. We'll look at some of these. 0.23, 0.23 ohms, 0.25 ohms. Some of the heavier current ones will run at 1.7 ohms. But they start out at a high value. They can start out as high as 150 ohms in some cases and drop down to less than an ohm when they're warmed up. They do run hot, but it's a good way to preserve tubes in these old radios if we can find a source of them for 1/4 of an amp steady state draw. Okay, we've covered the surge, we've covered some comments. I am going to set up here and prepare to show you how to tune that thing up or align the RF on it without a signal generator. Give me a second, boys. Alrighty, we're set up to do our alignment without using a signal generator, and I know I'm going to get admonished because somebody's going to say, software defined radio, they're not cheap. No, they're not, but most or a lot of the viewers out there are probably ham radio operators, and they're going to have a fairly modern receiver, transceiver, and they usually have a waterfall display like this. In this case, we're operating on the SDR Play RSPDX software defined radio. That's this little guy right here. Well, we're also going to use an Alinco DJX10 digital tuning on the radio. You can use something like, what's the name? I hope I pronounced this right. Sangyen receiver. They're pretty common. They're not very expensive. They have a digital readout. Shortwave radio with a digital readout. And we're going to go ahead and align our receiver without using a signal generator. It's a fairly straightforward process, just as accurate as using a signal generator, maybe even more so if you're careful. You can hear some humming in the background. That's just my isolation transformer up there in my Heath kit. So don't panic. It's done that since day one. It's just, I think it's actually the Variax noisy, but it doesn't hurt anything. Okay, where to start? Well, first of all, we're going to mention a couple things here. On this schematic, it's showing a trimmer capacitor on the antenna loop circuit, that resonant circuit up here. That doesn't exist. Just take that out of the equation. If it does, your instructions will tell you what to do with it. There's so many versions of this radio that, this schematic probably didn't get updated all that frequently. A better receiver would have some way to tweak the oscillator coil as well as the tuning capacitor, so you could tweak the low end and the high end and compress or shrink the spread of the oscillator to make tracking go perfectly. This was an inexpensive set. The only trimmer on here is on the tuning capacitor. So basically we can only adjust or compensate for the high end of the tuning range. And what you'll end up doing is, if you're not within the tuning range, let's say you ended up over here, we'll just shift the whole thing so it'll be off a little bit on this end and off a little bit on that end on the dial. So no worries, these radios were never meant to be precision shortwave receivers or precision receivers. The more money you spent on them, the better the dial increments would be. But I mean, look at the, look what's on the dial here, 55, 60, 65, 70. It just puts you in the general vicinity of the rate of the frequency you want. So what I'm going to do, I'm going to pick two arbitrary numbers, because typically they have you go high end and low end to net these receivers in. I am going to use the frequencies of 1.6 megahertz and 600 kilohertz. And the reason I'm doing that gives me a high end alignment, a low end alignment. These numbers are not cast in stone. Plus our 455 IF gives us 2.055, and on the low end 455 it gives us 1055. It makes the math easy, and it makes setting the receiver up easy. All I've got to do is jump 1 megahertz between the high end and the low end and align my receiver. We're just keeping it dirt simple. And I know someone out there is going to say you're supposed to do the IFs first. It isn't that important, and I'll show you as we go how we get around aligning the IF first, okay? You'll understand when this is done. So we'll get this out of the way. Now what I'm going to do, I don't have the tuning indicator here. I hope we're in frame. Yeah, we're in frame. So all I'm going to do is, I know the tuning indicator is centered on the knob. I'm going to put this on 160 and call that close enough. Now over here on my software defined radio, and we'll show you again how to do this using this set in just a second. Anything with a digital tuning on it. I'm going to put this, because we're on 160, 2.055. And I see this white line down here. These other spikes are probably just my fluorescent lights in the background. I have my Chinesium camera supply unplugged. We're running on battery. Keep your fingers crossed. But right here on this white line, can you see the cursor, I hope? This is where my local oscillator is sitting, and it should be over here, right there on 2.055. Remember, it was 1.6 plus 455. So what I'm going to do, if I can find the screwdriver I just laid down somewhere. There it is. Alright, I am going to trim my capacitor on the tune. This is my oscillator section, this is my antenna section, and again, a better receiver. Well, maybe there is in there. I didn't see that before. I'm lying to you. There is a trimmer for the antenna coil. Okay, we'll get to that when we get to it. Very good. I'm glad to see that. I was looking for it back here. It said it was on the loop, and it wasn't. But there is one on the antenna section. So I lied to you. The antenna section on this does have a trimmer. I see many of them without it these days, or on the cheaper sets. So this is for trimming up, padding our oscillator, netting it in. So I'm going to swing the camera back over here, and up here we have a highly expanded scale of what's down here. It's just a much narrower spectrum spread out. But I'll watch this to start netting it in, and then I'll go up here to exactly zero it. Remember, we're tuning our local oscillator, and you can see it moving across the screen. Come on, keep going. Whoop, went past it. this thing's touchy. And when you get it on, netted, oh, we got lucky. The zero beat will go away. I'm running this in double sideband mode. It'll also work in single sideband, upper sideband, or lower sideband. But using those, you see, you lose track of what's going on this side. So by using the double sideband mode, I can see that, and the oscillator's already drifting. Believe me, that's not the SDR moving. That's the oscillator and the radio. This is normal. Don't lose any sleep over it. I see people get all jacked up and wrapped around the axle because it moved. Let's see how much it actually moved here. Let's expand the scale. Right now we're off about, well, let's go up another scale here. This is 100 hertz, so we're off about 75 hertz. You're never ever going to see that on the dial. It just isn't that important. You saw how spaced out and how crude the dial was on this thing, and I'm playing with this just to be silly at the moment. Come on. This is so typical for these sets. It's high. I guarantee by the time I finish doing this, it'll be low. Oh, all I did is tap the radio. They're never going to stay any closer than a couple of hundred hertz, trust me. Not on this type of radio. So, what I'm going to do now to check the tracking on the dial, that was 160. I'm going to swing this down to 60 kilohertz. I don't know what it looks like in your camera. I'm looking at it straight on. You probably got some parallax. That's on 60 or 600 kilohertz, excuse me, not 60 kilohertz. That's 600 kilohertz. And I'm going to swing back over here. Hopefully I'm not making you dizzy or seasick. I am going to change this to 1055. Remember, 600 and 455. And you can see it's a little bit high. It's a little bit off the scale. So we'll try to net it in a little bit and split the difference. Now again, we're splitting hairs here. If you had the oscillator pattern on the on the oscillator, you would pad this down a little bit, then go back to the high end, net it in, come back here, net this end in with the pattern on the coil. The other end would be the pattern on the tuning condenser, back and forth until you shrunk or stretched the band spread until it matched the dial. On this radio, we're so close at this point, it's really silly to even play with it. But I'm going to do it just because. Yeah, there we go. And I brought it a little bit closer. I cut about half of the error out. Now I'm going to go back to the other end. And line up on my 160. And we went a little bit high there, so I'm going to net that down a little bit. We kind of just have to split the difference is what we're doing, because we don't have the ability to tune both ends of this. I'm still off the end of the dial here, so I'm going to bring it in some more. These sets are never going to be precision. I'm going to leave it there. Let's see how we look at 600. Get this tuned down here first, and we'll bring this down to 600. And that's looking pretty darn close at 600. Let's go back up and take a look at 1600 on our dial. It's right there, or as good as I can interpolate on that little strip of paper that's inside the wheel. So your RF alignment is done. Now again, if you have a more sophisticated set that actually allows you to adjust the oscillator pattern, you could net that in. You know, you could shrink or expand the dial by raising and lowering either end as needed until it was the right width, and then center it up. How do I do it with this one? Well, it's very simple. I'm going to turn this on. Let me swing back over here. We'll turn the pan down a little bit. There we go. And I've got 1055 on here. I'm on lower side band. And when I'm 0 beat, I've got the 600 almost in line with the center of the radio. Then I go 2.055 and go up and look at the high end. Almost dead in line with the volume control. Our oscillator is aligned, is working correctly. That's the correct calibration for the oscillator. Let me turn off this SDR, or turn it down, excuse me. Okay. Now, the RF front end is aligned. We haven't done the antenna yet. We'll get to that in a second. The RF front end is aligned. What do we do about our IF, our intermediate frequency? Well, our intermediate frequency wants to be on 455 kilohertz. Here you're going to need to know one of your local radio stations, what their frequency is. I've got one here that I can pretty much guarantee is on 610 AM. So I'm going to use that as my reference. I'm going to tune that one in, and we're going to take a look at the IF. We're going to find out exactly when we have the IF at 455. Remember, coming out of the oscillator converter up here, when we have our oscillator tracking correctly and our radio frequency signal coming in, those two are going to beat to exactly 455 kilohertz, because we've just set the oscillator up correctly on frequency to mix correctly to produce 455. Does that make sense? I hope. We want a 455 kilohertz conversion. So on 600 plus 455, we aligned it for 1055. But coming out of the converter tube, we're going to have 455 kilohertz. So what I'm going to do, and you shouldn't be doing this unless you got a lot of confidence in what you're doing, because now we're going to get into the high voltage. I have here a 200 picofarad capacitor for coupling and isolation. I want to isolate because I'm going to couple to my antenna to the output of the converter tube, and there's going to be some voltage there. I don't want to blow up my SDR radio. We're going to be coupling to pin 3, and there's 90 volts present there, but this is where, without being affected by either IF transformer, this is where we're going to have a signal at 455 kilohertz when we are on our 610 frequency. It's going to convert, the oscillator is going to convert that to 455 kilohertz. Therefore, on my receiver, we're going to go 455. I'm going to set that to 0, set this to 4. Now it's set up to receive a 455 kilohertz signal. Where am I going with this? Patience, grasshopper. Now I'm going to connect to the output of the converter, and remember, have your isolation transformer and be careful. There's 90 volts on this pin. That's why I have that that coupling capacitor, that 200 picofarad capacitor to isolate the voltage. Then I'm going to come over to my radio. What have I got to turn off to get rid of some of the noise here? Let me try this. No, still don't have my polarized plugs yet. They came in from Amazon. They were advertised as polarized. The picture showed them polarized and they were non-polarized, so those are going back. Alright. What the heck? Oh, I'll bet that's the camera itself doing that. I didn't have the camera on earlier when I proved all this out. Probably the camera making that racket. Let's ignore it. I know this station is on 610. And we should, when I'm dialed in exactly, because we know our oscillator's correct. So when I tune the radio, there's our 455 kilohertz. Now it's off a little bit. I'm going to turn the radio volume down. I am going to put this receiver on AM and turn the volume up.
Political ideology based on if they wear a mask when they don't have to.
Now we're listening to the intermediate frequency. And if I put this exactly on 455 kilohertz, now I don't know if I'm going to be able to get it. Oh, I hit it. Look at that. We're exactly centered on the 0. So the radio is now tuned to 610 on the AM dial, because it is producing 400. Remember, we know our oscillator is correct because we just aligned that. So now I have a 455 kilohertz signal here. And I know that 455 kilohertz signal is accurate because my local oscillator is accurate. And the radio stations by FCC mandate have to be within, you know, a couple hundred hertz of being directly on frequency. So we know that's a reliable reference, the 610 radio station. We've reliably aligned our oscillator. Now we have a reliable 455 kilohertz signal to align our IF section with. That makes sense? I hope so. Without touching our tuning dial, it's important we don't touch the tuning dial at this point or we'll lose our 455 kilohertz reference. Let me try turning off some of these lights and see if it gets any better. I think that's the camera. Yeah, pretty sure. Maybe it's the computer. Yep, computer power supply. Okay. Remember, we can't touch our tuning dial because we've determined that right now we know we have a 455 kilohertz signal. Now, before I started this process, I verified that these capacitors are cold. You always want to take a voltmeter from chassis ground to your tuning capacitors. If your IF cans are the type that tune with tuning capacitors, some of them use permeability tuning where it tunes a slug inside the coil. These are, I don't know what's with this camera. It just shut itself off again for some reason. It's not out of memory and it's not out of battery. It just shut down. It's been starting to do that lately. Where was I? Oh, okay. I know my trimmers are cold. So I can use a regular screwdriver, although that still isn't good practice. You should always use a tuning tool. But I've played with this set enough, I know it doesn't affect it any. And we're, oh, they're up here. You can use a set of ceramic screwdrivers, those are available online, or you can buy a set of these or both. It's nice to have them both on hand, actually. And there's the one for the IF transformers. And what I'm going to do is just peek it. And then, yeah, you always see them doing it with a voltmeter and a signal generator. It's not that critical. Not that critical. There we go. That was an improvement.
Here at the courthouse, that is not been the case at all. I mean, even the prosecution's own witnesses have bolstered Rittenhouse's claim to self-defense. So there's unfortunately still a large part of the American population that have this really distorted, really just untrue view on what happened that night.
There we go.
I can tell you that because, I mean, I was there for
now, as you do this, if you're on a really, really strong station, you'll want to reorient it to get the signal weaker, because you don't want the automatic volume control actuating and dragging the signal down, because you'll get a false tuning. And this is working so well now, I can't even find a weak. Guess that's the weakest right there. Yeah, we pretty much nailed it. I'm probably in front of the camera, and I am. Of course I am. Yeah, I'd say we pretty much nailed it.
This has been the most I've ever seen it, and I've seen members of Huber's family, Anthony Huber.
And there's so much noise in this room, different things.
In the courtroom, some friends and
but
supporters.
There you go. I can't even turn the volume down low enough to shut it down. Tune it off the station. There you have it. There's your alignment. And you can do it with one of these. You can do it with one of the SDR radios. You can do it with your ham radio. Anything that'll tune down to those frequencies and has, you know, some type of display to allow you to know that you're netted in on frequency. And stuff like this has a PLL in it. These are pretty much dead accurate. Those software-defined radios over here have a software calibration, and I used my GPS disciplined oscillator. I've netted this thing in. These things lock right in on frequency. I mean, they're just about perfect. But anything with a digital tuning dial, like, you know, even one of those Sanguin receivers, will allow you to, well,
the shot him as a charged term had actually been banned inside of the courtroom. But the people he shot were white. Does that surprise you in terms of the way that it broke?
It's too early in the day to hear anything in here except 610. At night, this thing comes alive. That's simple, folks. Align your local oscillator using your receiver. You know, pick a couple of convenient points. Align your local. Oh, we could try the antenna. I didn't tweak the antenna thing, did I?
How even possible? Because I knew from that night that he shot all white people.
Usually they have you align this thing
How does this congresswoman from that, you know, on the East Coast,
on the low end.
like what information does she have?
But whatever you've got off the air.
She just, you know, she jumped the gun on this, and so many others too. But it just goes to
Come on, get on the screw, dummy.
Again, they have this idea that there can be no wrong done with a Black Lives Matter riot, because let's be clear, the night of August 25th, it was.
that's pretty much netted in. That was a very weak station, and I peaked it on that. We're done. We can throw this back in the cabinet, and you can display it or play it or put it on the kitchen shelf and listen to it while you're cooking. Simple as can be. No test equipment required. I'm the radio mechanic. Hope somebody found this information useful or helpful. I got an email or an update today. The other radio should be in this week, and we can revisit this just to reinforce everything we've learned so far, and preserve those old radios, folks. Let's keep some of history alive. And I was just about to sign off here, but I watched, I don't know if you guys watch Fran Lab, and she was on last night, and she seemed pretty down in the dumps because she's once again being forced to move, and her collection, her hoard as she calls it, her curated hoard, which we all have if we do this, I had to commiserate with her because she's worried about what's going to happen when she passes on, as am I. And luckily I've lined up a fellow that, if I was to drop dead tomorrow, my sister knows who to contact. He will back up with a truck and take all of my stuff to his lab so that at least most of it gets preserved. But it was just interesting to hear somebody worrying about it as well. I have so much stuff downstairs. Vacuum tubes and antique parts, and of course all of this restored test equipment that's here, which I absolutely love working with this old gear. And those of you who know me know I have a full-blown lab downstairs in the basement as well. Ellsworth, Illinois. I don't know anybody in Ellsworth, Illinois. I have a full-blown lab with semi-modern equipment downstairs. I get more of a kick out of working with this stuff, to tell you the truth. It's just fun to visit, how they did it back in the day. I love that VTVM with the huge, that's a good-sized meter on the front of that. I love that thing. I think Hickok made one that was even bigger. And they used to show them up on the top shelf, way up over the top, so that the technician could have his meter off his bench out of the way and still easily read it. But I love that old ICO. And I really, really get a kick out of working with these old capacitor analyzers. This one's set up here that it's got a megohm meter built into it, so I can test leakage. It's also got a VTVM built into it that I never use. It's just too clumsy to use. But, the technician could have bought this one piece of gear back in the day and had his capacitor tester, his leakage tester, and his VTVM all built into one unit. This little guy here is still my favorite. It's simple. It's dead accurate. I put a couple of precision reference capacitors in there, and the thing is like on the money. It's just so much fun to work with this stuff. As old as it is, it just continues to work perfectly. Okay, enough rambling, enough reminiscing. I'm the radio mechanic. Thank you so much for tuning in. The next video may be 3, 4, 5 days, a week out. I've got some work to do around the house, and I'm still waiting for another radio to arrive. Winter's coming fast. I've got to get some done stuff. Yeah, some done stuff. Bleh. Some stuff done. Some work done, and then we can get back to playing radio. Take care. See you soon. Bye.